In this video, we're going to solve the following related rates problem. Car A is traveling west at 50 miles per hour, and car B is traveling north at 60 miles per hour. Both are headed for the intersection of two roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? So first, let's start by drawing a diagram. So we have two roads that intersect, and we have that car A is traveling west at 50 miles per hour. So let's say car A is over here, and we know that car A is driving west. Now I have car B, let's say car B is over here, and car B is traveling north at 60 miles per hour. So I'm going to label some variables. I'm going to let x be the distance. So we'll say let x be the distance from car A to the intersection. And I'll let y be the distance from car B to the intersection. And what is it that I want to find? I want to find at what rate are the cars approaching each other when car A is 3 miles and car B is 4 miles from the intersection. So we'll let this line between A and B be z, and so ultimately we want to find dz dt when x is 0.3 miles and y is 0.4 miles. So this is what we want to find. What information do we already know? Well, we know that car A is traveling west at 50 miles per hour. So that tells me that dx dt is equal to minus 50 miles per hour. And we also know that car B is traveling north at 60 miles per hour. So that means that dy dt is minus 60 miles per hour. Now both of these derivatives are negative, and you might be wondering why. Well, the derivatives are negative because as the cars are approaching the intersection point, the distances x and y are getting smaller. So we have that these are negative. Okay, great. So we want to find dz dt when x is 0.3 and y is 0.4. Now can we think of an equation that can relate x, y, and z? Of course we can. We have a right triangle. So we can use the Pythagorean theorem. So we have that x squared plus y squared equals z squared. Now we can take differentiate both sides of this equation with respect to t, and we get 2x times dx dt plus 2y times dy dt equals 2z times dz dt. Okay, now we can simplify a bit. We can divide everything by 2. So all these 2's go away if we divide both sides by 2. Now we want to solve for dz dt, so we want to isolate that, and we can do that by dividing both sides by z. So this becomes dz dt equals 1 over z times what we had on the left-hand side. So x dx dt plus y dy dt. Okay, now we're close to being done. So we wanted to evaluate dz dt when x is 0.3 and y is 0.4. So we have values for x and y. We're also given these rates. So we have values for dx dt, dy dt. The only thing we don't know is z, but we can solve for the value of z using the Pythagorean theorem. So using this and the fact that x is 0.3 and y is 0.4, we can solve for z. So we have 0.3 squared, so we have 0.9 plus 0.16 equals z squared, so that's 0.25 equals z squared, which means that z equals plus or minus 0.5. Now, it doesn't make sense for us to be considering negative distances, so we just consider the positive solution. So z equals 0.5 miles. Now, we'll go back to our equation and plug everything in. So this tells me I have 1 over 0.5 times 0.3 times dx dt, which was minus 50, plus y, which is 0.4 times dy dt, which was minus 60. And if you plug all this into a calculator, you should get minus 78 miles per hour. So what does this mean? This means that the cars are approaching each other at a rate of 78 miles per hour. So let's do a quick recap of what we did. So first, we drew a diagram to understand the situation, and then we labeled two variables that we know, the distance between A and the intersection and the distance between B and the intersection, and then we figured out what it is we're trying to solve for, which is the change of rate of the distance between the two cars as they approach the intersection. We then came up with an equation that relates all three variables, and then we differentiated both sides with respect to t, and then we used the information we were given to solve for the information we wanted to find. And this is our final answer. If this video was helpful, feel free to like and subscribe.